This will likely be the most controversial lesson of Agentic Horizon. There will be 3 buckets of engineers that watch this lesson. Those who dismiss this idea, those who give it a shot, and those who say, this is what I've been looking for. Agents of today have many problems. Most of them can be solved with great context engineering and great agentic prompt engineering. But there is one massive problem that persists no matter how great your context engineering or agentic prompt engineering becomes. Traditional software improves as it's used, storing user analytics, usage data, and patterns that create algorithms. Agents of today don't. The massive problem with agents is this: your agents forget, and that means your agents don't learn. There are a few solutions, but each has their own problems. Memory files are global forced context that always loads. As you know, expertise requires breaking rules when the time is right. Memory files also must be manually updated, consuming your time or your team's time. Then we have prime prompts, subagents, and skills, powerful agentic tools. But again, these all have to be manually updated when you want to add new information and steer your agents in a different direction. So, what if you could take the best tool for the job of engineering, agents, to the next level by teaching your agents to act, learn, and reuse its expertise at runtime? What if you could create agent experts? The difference between a generic agent and an agent expert is simple. One executes and forgets, the other executes and learns. In this lesson, I'll execute and you'll learn to build agents that turn actions into expertise, automatically storing the right information and reusing it with no human in the loop. This is key. This is what makes an expert an expert. You don't need to tell an expert to learn. It's in their DNA. Also, real experts don't relearn their craft every time they have a new task. True experts are always learning. They're updating their mental model. This mental model is, simply put, a data structure that evolves over time. With each useful action, experts accumulate information, examples, and ultimately expertise around a specific topic. This is key. You're not trying to solve every problem. You're trying to solve the one that matters the most to you, your business, and your customers. If this sounds familiar, it should. You and everyone you admire has a strong mental model around a specific domain down to individual problems. This mental model is a data structure that helps you solve problems better and faster as you act, learn, and reuse that expertise. So in the world of agentic coding, prompt engineering, and context engineering, what is an agent expert exactly? The agent expert is a concrete form of a self-improving template meta prompt. That's a mouthful. Let's break this down, because if you understand meta prompts, you will understand agent experts. Meta prompts are prompts that build other prompts. Template meta prompts are prompts that build other prompts with a specific purpose and structure. This is a key leverage point of agentic coding we discussed in lesson 3 of tactical agentic coding. This is how you teach your agents to operate and build as you do. Now, self-improving prompts updates itself, related prompts, or an isolated file with new information that will be used during your agent's next execution. When we put it all together, you get a self-improving template meta prompt. If that doesn't make sense, don't worry. We're going to walk through it step by step in this lesson. There are people who are proficient. There are engineers who are great, but experts are in their own class above the rest because they never stop learning. Experts grow. They update their knowledge about their domain. The expert understands that the game they're operating in never ends except for one condition: the moment they stop learning. I don't know about you, but I certainly want experts operating my code base and products, not generic agents that forget that you have to boot up over and over and manage the memory files of manually. That's the focus of this lesson: agent experts. In this lesson, we'll walk through meta agentics, or put plainly, no fancy language, meta prompts, meta subagents, and meta skills. We're going to do this to showcase the atoms of what makes up the agent expert. We'll use our orchestrator agent from lesson 4 to showcase agent experts that operate specific areas of your small to large code base extraordinarily well. This is one of the killer use cases of an expert. We'll then take a look at a product-focused agent expert that let you build adaptive user experiences, a whole new untapped type of UI UX waiting to be unlocked by engineers like you who are willing to push the boundaries of agents. Let's start with meta agentics, the building blocks for not just your agent expert, but your entire agentic layer. At their core, meta agentics help you build elements of the system that builds the system. As mentioned, these include your meta prompts, your meta agents, and your meta skills. It's important we touch on these because they greatly increase your output as an agentic engineer. With or without agent experts. Let's run through each to showcase their value proposition. In this agent experts code base, you'll have access to in your loot box below. We'll start with our meta prompt and we'll have it create a new version of a question prompt called question with mermaid diagrams. We'll fire that off. Let's fire off the meta agent, the agent that builds the agent. We're going to have it create a new planner agent that directly reads and executes the plan prompt. This way we can scale up planning to multiple agents in parallel. And finally, we'll use the meta skill to create a start orchestrator skill that's going to kick off the front end and the back end of our multi-agent orchestration application that we covered in lesson 4. Meta agentics are critical because they let you build more of your agentic layer faster. We have prompts writing prompts, agents building agents, and skills building skills. There is no code base I create that does not have meta agentics. Every code base must have meta agentics. Let this be a reminder to always use and have a stack of these ready to go to help you build out the next thing. They serve as the foundation to quickly spinning up new agentic layers, which will be the topic of discussion in the final Agentic Horizon lesson. We have our question with mermaid diagrams built out here. You can see in our classic agentic prompt format, we have a great structure here, and our variables just takes in the user question, and then based on the purpose, you can see exactly what's happening here. The key is if we search mermaid, you can see that we are always going to create mermaid diagrams that enhance understanding. We have a powerful question prompt that was built out by our meta prompt. We then had our meta agent build out a new planner agent. It takes in, right, it simply reads an existing prompt and it fires it as a sub-agent. This is a powerful way to reuse and scale your existing prompts into their own agents. Lastly, we have our meta skill. And our meta skill took our existing process of kicking off the orchestrator front end and back end, and we can now use it as a concrete skill. If we open up our start orchestrator skill, you can see exactly how it works. You can see the exact purpose. Start orchestrator 3 front end and back end. It has the flags. It has the details of where to go, how to start them. It's even going to open it up in Chrome for us after it's finished. And this was all built out thanks to our meta agentics. Meta prompts, meta agents, meta skills. Now let's ask an important question. Are these meta agentics agent experts? They're acting, but they're missing a key piece. They're not learning at all. Nothing inside of the meta prompt, the meta agent, or the meta skill has updated automatically. Our meta tools are not becoming more proficient. Therefore, these are not agent experts. This is a key factor of what makes an agent expert. They must learn on their own. Agent experts must learn on their own. Now, you teach them to learn by, once again, templating your engineering. But after that, they must accumulate and manage their own expertise. Let's look at a concrete example, a set of prompts that start to look more like an expert operating your code base. So if we look at our .claude directory and we go into our commands where our prompts are stored, we have this experts directory. We have a database expert. Let's click into this and understand the 2 prompts in this new expertise file. Let's open these up, and before we deep dive into this, let's execute a question to our database agent. We'll type /question, and you can see our question prompts here. We'll tab on database question, and then we'll ask this. How does information flow between our database tables? Write your report in this temp file. So the first thing this agent does is critical, and it changes the flow of everything. It first reads this expertise file. Now, what is this? The expertise file is the mental model of the problem space for your agent expert. You can see it first read the expertise file, and then it started comparing its understanding against the actual code. And it did it instantly. It didn't need to go search or find these files. It knew where they were. This is the differentiated factor of an agent expert. It contains a working mental model just like you or I or any engineer on your team would. This is big. Okay, what we've developed here inside this YAML file, right, that could be any data type, this is, in fact, a mental model. Now, it's super important to just touch on this idea right away. You know, a lot of legit engineers might be thinking this. Isn't that another source of truth? Don't we now have the code, the comments, you know, the PRDs, the plans, product documentation, and this expertise file? This is not what that is. Let me be ultra clear about this. This is not a source of truth, okay? Just like the mental model you have of your code bases, right, of your products and code bases, all the tools that you operate, you don't have a source of truth in your mind. You have a working memory file. You have a mental model, a data structure that you constantly update when you need to dive into a specific problem, a specific area, a specific domain inside your code base. All right. This is what this is. This is not a duplicate. This is your agent's mental model. We can see that it has created a comprehensive flow of our database. Let's open this up. Let's go into our preview view here for this markdown file. Database information flow report. To be super clear, we are pointing our agent toward the multi-agent orchestration application. This could be anything, all right? System uses 6 Postgres database tables to track orchestrator agent command, their communications, and logging. We have a parent-child pattern that cascades deletes, all right? So we have an entity relationship diagram there, great breakdown. You can see all the tables, how they relate. We have information flow patterns. We have 3-way communication between the user, right? You or I, the orchestrator, and they respond back to the user, but also they can talk and communicate to the agent, and then the agent responds to the orchestrator. This isn't about the multi-agent orchestration system. We're just pointing our agents at this domain. All right, so there's a ton of details here. The key here is this. We had an agent very quickly use its mental model. It validated its mental model against the source of truth. The true source of truth is always the code. You and I know that. Not the comments, not the documentation, not the plans. It is the code. The code is what runs and builds the product. But that does not mean that auxiliary documents and memory and mental models, right, expertise, it does not mean that they're not ultra valuable. And you're going to see that over and over again here. What does this look like? What is in this expertise file? And before we get there, just to, at a very high level, break down the question prompt, you take in an argument, and our question prompt also has a static variable that references, of course, the expertise file. And the first thing it does is it reads this, all right? And the workflow, it reads this right away. And then it validates its assumptions against the code base, all right? Super critical line. I have it in here twice for that reason, all right? Only then does it actually report. So that's the question prompt. Now, what is the expertise and how do we build it? So if we just collapse this, you can see here, this is just a high-level map of the understanding our agent has built up of the database of the application, okay? And so we have just selected the database because we want expertise around this, right? Databases, for many applications, it does represent the source of truth, the most important kind of building block that every other piece of your application is built on. The database is just a great classic example and a great place to build an agent expert. Now, what is actually in this file? Right away, very interesting here, right? We have an overview. Okay, Postgres database layer. Here's some of the tooling we're using. Lightweight Pydantic models over SQL queries, no heavy ORM. Okay, so very interesting here, right? We're starting to define the high level, just like you or I would, right? Oh yeah, and that code base, we're using Postgres, we use Pydantic models, we use raw queries there instead of going for an ORM, kind of interesting. And then we have some idempotent SQL migrations, okay? So pay attention to how close this is gonna feel to your understanding of some of the code you operate in, all right? Core implementation, what's in this? Let's go ahead and collapse this a little bit. Database module, okay? So that's where the database is. We have a connection pool, interesting. We have the purpose of that file. All right, that's the purpose of that specific unit of code. Perfect. Query patterns. All right, we use raw SQL, parameter substitution. Pydantic models. We use JSONB handling with dumps. Okay, interesting. Data models. Okay, models, features. Interesting, right? It's just kind of defining the table as it is, right? What's the agent log? It's the agent logs table. Duh. Obviously, right? So we have this distribution file that when it runs, it syncs to another location, and there's the script that does it. Okay, interesting. We have a way to distribute the data models across many applications. We also have schema migrations, right? So notice what's happening here, right? We don't need to go through this whole thing. This is a mental model. It's not a source of truth, okay? You can think of this and all really, all secondary, tertiary pieces of information about a code base or about a core product. All of it is a rough approximation of what's truly there, right? Of what's truly in the code. You have a mental model, your team has a mental model. Give your agents a mental model by giving them an expertise file, all right? Now, how do we build this? We, of course, built this with the self-improve prompt. Now, what is in this? Let's start from the top, right? You maintain the database system's expertise accuracy by comparing the existing file against the actual code base implementation. Again, I want to be super clear here. I'm communicating this to my agents. This is not a source of truth. This is not documentation about something. This is we're getting to it in a second here, follow the workflow to detect and remedy any differences, missing pieces, or outdated information, ensuring the expertise files remains a powerful mental model and accurate memory reference for database-related tasks. This self-improve prompt is going to keep the mental model synced. Let's just run this. Self-improve, database. We have a couple additional flags here. We don't need any of them. Let's kick it off, all right? Let's let our agent sync its mental model with the working code base. And so you can see what's coming here, right? What is the self-improve prompt? It is, in fact, that template meta prompt that defines how we want to update this related file that is the expertise for this specific problem. Okay, and so here we go. Our agent is just going to burn through top to bottom everything it needs to understand what's going on. And if something is out of sync here, it's going to update it. So here it's doing a validation check. We, of course, have closed loop prompts inside of this. There we go. We have a great breakdown here of all the lines and the truthiness of them. But you can see here that it validated, right? We have a validation set in here. The expertise must be managed. So if I open up variables here, you can see I have max lines. And so it checked the line count and it compiled the YAML file. All right. So we're making sure this is in a concrete data structure. All right. Of course, to be clear, you can use whatever data structure you think is best. There's definitely always a better data structure that's easier for your agents to understand and read. I like YAML. I've seen great results with YAML, but of course, TOML, JSON, CSV, right? There are many other formats that you could put and structure data into. Now, the interesting part about this is, of course, if we open up the workflow, you can see exactly how this works, okay? So step-by-step play. Again, a classic agentic prompt structure. If you need to reaffirm and improve your prompts and be consistent with them, always check out Agentic Horizon Lesson 1, Agentic Prompt Engineering. You'll notice over and over and over and over, all of the prompts I write now are in the exact same format where the details are the only thing that's changing. Why? It's because consistency gives you trust. Check this out, right? Get diff, read current expertise. The first thing it does, validate against the code base, identify discrepancies, update your expertise. And then we have our closed loop prompt. Your agent must know how to manage its memory. The interesting thing here is that I'm not being ultra prescriptive about what should be stored here. And this is something that's called seeding your data or seeding your data structure for your agent. I did not do that. I let my agent define the structure. It defined it, and now it's maintaining it. And let's see if anything needed to change there. Check this out, right? Summary. After thorough validation, the expertise is accurate and up to date, right? Everything is perfect, down to the line numbers, okay? In this file, there are, line numbers. I don't know where we can find one here quickly. There we go, line XYZ, right? 44 instances of specific line numbers that connect and that are important for the key operations, okay? Very, very powerful pattern, okay? I'm not being ultra prescriptive here, but this is where you can start to really dial in and again, template your engineering for how you want this file to be written. So I'm being quite loose here. I want my agent to guide the structure, guide the experience. And when there's a change, maybe we'll add like an ORM, right? And then our agent will have to update the structure or key ideas inside of the expertise file. But that's all up to my agent expert, okay? It's the expert. And there's something important here. We do say, at some point here, we should call out something like granular, right? We don't want to be too prescriptive, right? Prioritize actionable, high-value expertise over verbose documentation, okay? And we also have this really great line here, and very important for some language models and some agents. Keep in mind, after your thorough search, there may be nothing to do. This is perfectly acceptable. A lot of agents are always trying to do things. Make sure, especially when you're building out these kind of advanced prompts, right? Self-improving template meta prompts, you need to tell your agent what is okay and what is not okay. All right. So anyway, this is a 99-line prompt. Self-improving, updating the expertise file based on real changes in the code base. This self-improve prompt is telling us that our agent's mental model is synced with the ground truth. This is the equivalent of you going into the code base, refreshing your memory on a feature before you start building and adding on to it. Okay. Once again, here we are. We have another round of scaling up our compute. More compute equals more confidence, and we're templating our engineering into our agentic processes, right? Into our leverage points of agentic coding. Here, we have a prompt, we have a template meta prompt, and we're teaching it about our code base architecture. So interestingly here, we still just have a partial expert. Agent experts have 3 concrete steps, all right? You can boil it all down to just 3 steps: act, learn, reuse. Act. First, our agents take a useful action. The keyword there is useful. Then our agents learn and store new information, right? This is our expertise file getting updated. Then they reuse that information during the next execution directly from that mental model. Keep this in mind as we work through our agent experts here moving forward. Looking at our database expert, what steps do we have? We have a reuse step because we are concretely reusing this information during our question prompt. We also have a learn step. This is what our self-improve prompt does. Your agent has a rubric for how to learn and store that information for the next execution. Now, where's our act step? We don't actually have any action prompts here. Nothing is changing. Now, in this current version of this database expert, which again is completely acceptable, all these patterns and kind of new workflows and new types of agents we set up, break all the rules to get the job done, right? Define these things however you want. We just need a common language to communicate these new ideas through. So we call it agent expert. We have 3-step workflow, yada, 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 okay? But feel free to break all these rules when the time is right for you to ship, okay? I don't do this to try to sell you ideas. I'm here to deliver concrete engineering value to you and your team. Now, we are missing this act step, and this is critical for this 3-step workflow. Now, what is acting in this scenario? Acting here would be updating any code related to the database of this system, right? Now, we just don't have that step here. Right now, this is still not a complete agent expert. There's no action. It's not taking any action. So in our next example, we're going to see exactly that. We have a WebSocket expert that we're going to dial into, and right away, you can see where the actions are. This WebSocket agent expert is going to perform any out-of-the-box agent. Why is that? It's because it has a mental model of work already completed. It has a mental model of the WebSocket system. Let's dial in. So before we take a look at our WebSocket expert at all, let's kick it off. I'm going to use that 3-step agentic workflow here, /plan, build, improve. And we're going to do this. Add a session-based counter to the app nav bar that displays the total number of WebSocket events, right? Perfect for a WebSocket expert. It knows where all this stuff is. There's no searching here. There's just validating its mental model. So we're just gonna go ahead, kick this off right away. And to be super clear, we are, again, operating in our multi-agent orchestration application. We are having our agent add to this, right? So we have active, running, logs, cost. It's going to add a WebSocket counter here. Just a simple example showcasing how you can have an agent expert that knows that code the best, better than anyone, quickly update something. Before we dive into this, let's just fire off some more prompts, right? Let's have some fun with our multi-agent orchestration tool here. And you can see here that we also have our expert and we have our WebSocket expert specifically. And I just want to run this question prompt here. Okay, so I'm just going to click this here. I'm going to ask what WebSocket events exist in our system. I'm just going to fire this off, and actually let's scale this up. So I'm going to say create 3 agents and run this. This is an agent orchestration system. We can easily, quickly scale up more agents against a specific problem. And this is a really cool way to co-locate on the right answer. Instead of having one agent answer something for you, have 3, have 5, have 10, right? Depending on how important it is that the answer is correct. So there we go. Our orchestrator agent is going to kick this off. It's designed a specialized system prompt, and it's going to do this work on our behalf, okay? We covered the agent orchestration in lesson 4. This is not about the agent orchestration system. We're just going to use this to showcase how powerful agent experts can be. We have now deployed 3 WebSocket agent experts to answer one question. When they come back with their answer, we're going to be a lot more confident that they're giving us the right answer. So you can see there, we've fired the exact same prompt to every single agent, right? What WebSocket events exist? Same thing here, same thing here. We have 3 WebSocket experts getting work done for us, finding the answers to question for us with their existing expertise, okay? So let's go ahead and take a look at how this all works, all right? So we have multiple agents working in different systems. Great. If we click expertise, you'll see a very similar structure. It's going to collapse everything. And this makes sense, right? Our language model that built this likes to use relatively consistent patterns that it's seen inside of its existing training data that built the language model, okay? Here we have a WebSocket implementation expert, and it's driven by this 3-step workflow, right? We can now plan, build, and improve anything related to WebSocket functionality in this code base with a single one-shot prompt. And to be clear, this prompt does compose other prompts. Let's go ahead and collapse this. Let's be super clear about what's happening here. Right, we have a 3-step workflow where each of them is going to kick off a different sub-agent. We're going to create our plan, so a classic planning step. We're then going to build against the plan. You've seen this before, right? This is classic prompt chaining via an agentic workflow. We're putting together prompts so that our agents do more, and then we're scaling it out to different agents. We are using sub-agents here to get this work done. You can see we are creating our WebSocket plan to get this work done, all right? So we have that build step, and then we have our self-improve step. Okay, so all of a sudden, things get really interesting here. We're not just planning and building, the code base updates, source of truth updates, but no one's keeping track. No one actually knows what's changed. You, the engineer, have to jump in, understand what happened, validate what happened, keep track of the changes somewhere, create some review documentation. The agent expertise is ultra powerful because it lets our agent keep track of this. What we're doing here is we're really hitting on that key tactic from lesson 6. You want one agent working on one prompt with one purpose. All right. Even in your agentic workflows where you have many sub-agents or many primary agents because you've scaled up to a orchestrator tool like this, you still want them focused on a single problem. At step 3, we're going to run, guess what, the self-improve prompt. If we click into this for a WebSocket expert, you can see a very similar structure. It's almost as if I had an expert meta prompt generate this for me. Okay, hat tip, nudge, nudge, wink, wink. Once you start building something repeatedly in your system, you want to move that into automation, right? 3 times marks a pattern. I, in fact, do have a meta expert. It's doing exactly what you think it is. Check the git diff, read the current expertise file, validate against the code base. This is not an additional source of truth. It is a mental model for your agents. Identify discrepancies, update expertise. All right, and we're doing a little templating here, right? This is where the key templating happens. List all the differences, outdated, change methods, blah, 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 right? Add missing, update outdated, maintain YAML, and then we're doing some self-validating down here, 2 validation checks. We want to keep that, line limit locked in, and we're validating that this is valid YAML. If it's not, do it again, right? Structure it, fix it, okay? And so our plan is completed, and we're now building the application. We should see a counter pop up here at some point, but right now we did have our 3 WebSocket agents complete. You can see the application starting to live update. That's cool. I can open this up and ask based on, and I'm just gonna click, what WebSocket events, be concise, bullet points. Okay, so all of our agents have completed. You can see all the consumed files from that agent, this one, and our other one. And so I love seeing this in action, right? You can see the non-deterministic behavior in the files that each agent expert consumed. So 5 files there, 4 files here. And so we can concretely see this. Our orchestrator can synthesize all the results. And very interesting here, let's check this out, right? WebSocket 3 didn't complete the task. And so this is another key value proposition to scale up your compute. Sometimes if you throw 5 agents at the problem, only one makes it. One finds something the other didn't. The other finds some things the others didn't. And then you compose that together, you get a better result. Okay, so this is correct. My mental model can validate this. We in fact do have 21 types across, I don't know if there are 7 categories, but there are some 20 WebSocket events. So agent lifecycle, agent communication, orchestrator chat, system, blah, 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 blah. Okay, we had our agent experts build this out, validate this work, and you can see the UI flickering here because our build WebSocket agent is updating the store, and soon it's going to update the actual front end based on the plan. We've talked about this in previous Agentic Horizon lessons, but we are reducing and delegating our context. The plan step here took 80K tokens. Our top level agent here has its context completely protected. All it did was pass the return plan into the builder. And once the builder finishes, it's going to pass the get diff work, right? So just the work being done, right now we can run GS. We can see all the changes that's happened. And this work is going to be passed right into our self-improve. And we're actually going to run, and you can just see this, right? We're going to run self-improve with true, right? So we are indeed going to look at get diff. This is that first parameter here, right? Argument hint, check get diff. And this is going to be what guides our agent to update the changes that have been made. So this is going to be really cool to see this end to end, but you can see here 3 agent experts completed the work. And if we want to, we could have even scaled this up further, and we can say something like this, right? Create 3 more experts using the Opus model and have them same prompt to ultra validate. Okay. So we can do all types of things once we get these powerful orchestration systems and powerful expert systems up and running. All right, so we're still building, but you can see here, we have that brand new WebSocket events coming in, right? This is getting live updated. Frankly, the live update could have been the reason that Expert 3 failed. Who knows? Don't care. But here we go. We can see that diff stat. So this is part of that last step of our builder. It's summarizing the work done by looking at get diff. And then it's going to pass its work, right? Our top level agent here is going to pass off this work right into our step 3, which is our self-improve prompt. You can see it's written out exactly as is. There is zero confusion in this agentic prompt. We're going to plan, we're going to build, and then we're going to improve, and we're delegating to sub-agents. Ultra powerful stuff here. WebSocket build done. Check this out. 61K tokens, 41 tool uses. And we should be able to see this here. I'm going to go ahead and refresh. There we go, WebSocket event 1. There's another one coming in there. All right, and so you can see here our Opus orchestrator agents are fired off here. And in our last step here, you can see our self-improve WebSocket expert is kicking off. It is making updates, right? Things have changed in the system. And so this is going to be reflected. Brand new lines here that have not been committed. We have on message received. We have our WebSocket counter event, right? This is brand new. The total lines have increased. And I don't know how important lines are here. I guess it helps the agent search through total line numbers and maybe run some go-tos faster. But this is maybe something that could be played with. We can see if we really want this. But then we have something really cool here, right? Session state is keeping track of the state counter for all WebSocket messages. Of course, in the UI here, you can see we have some total 167 WebSocket events. So, that change was one-shotted, and you can bet that the guarantee of that performance was increased by having an agent expert that knows that code better than anyone or anything, right? We're entering this really weird phase where you can truly create high performance agents. And all you need is the right information, the right prompts, and then you can compose them into whatever you want to. All right. Many engineers, you might be thinking, just build a skill. That can be a skill. That could be an agent. That could be a sub-agent, whatever. It doesn't matter. Okay. Build whatever abstraction you want to. Build your own MCP servers, build your own skills, do whatever you want. I always focus on the foundational units. Okay. You know what they are: context, model, prompt, tools, the core 4. All right, everything is that, just with some fancy tooling, a little bit of code structure. Okay, build a skill if you want, build a custom agent if you want, overwrite the system prompt if you want. There it is. Our agent has finished. 20 tool uses, almost 60K tokens, right? You have to protect your context windows here and build focus agents that do one thing, total of 15 minutes or something. And then we have a great workflow summary. All right, and of course, this is built into the report format here, where our agent is summarizing each step. All right, so looks great. You can see all the exact precise changes made. Many engineers get super hyped when an agent changes a million things. I get super hyped when agents change just the right things, right? I want to see surgical changes like this. 5 lines, 17 lines, 9 lines, 4 lines, all right? And then we have our discrepancies change, and we can just see this, right? We can always prove it with Git. Here's our expertise file, GTF. What changed? You can see the exact updates your agent made to its expertise, to its mental model. And in fact, something really interesting you'll find when you start deploying these is that their mental model becomes yours. Sometimes, and we'll talk about the best places to deploy agent experts in a moment, but I've found myself more and more coming into these expertise files, particularly, one of my favorite use cases for the agent expert is around billing systems, is around systems that require security. It's around complex niche systems, right? It's around large code bases with many interconnected systems spread very, very far apart, right? Your average agent just wouldn't know to connect the dots like that. And even the best agents, the best models, it would take them quite a bit of time to search through everything to draw all the connections. This is why agent expertise and having mental models for your agents is so powerful, all right? We have 650 lines here of a map, right? A wrapper around the WebSocket capability between my backend and the front end of the multi-agent orchestration system. This scales very, very well. So anyway, so here's the Git diff, right? We can see all the expertise, yada, yada, yada. We can see everything that was updated. And if there's something we don't like, if there's something that's wrong or off, we're going to do something really important. We're not going to update the expertise file. And this directly emphasizes the trend of building the system that builds the system. You want to update the agentics that are operating your code. You want to update the self-improve step that operates your expertise. Okay, these are both the same thing. What I'm saying here is this is the key message of tactical agentic coding and agentic horizon. Build the system that builds the system. Do not work on the application layer. You're wasting your time. Someone like a lot of the engineers that take this course, we are building the agentic layer, the system that builds the system, right? The ring, the new ring around your code base that can operate it for you, with you, and without you, right? So that's what this expertise file does. That's what agent experts get you. Really focus on, don't directly update this expertise file, right? Teach your agents how to directly update it so they can maintain it, all right? Fantastic here. That is our WebSocket agent expert. We can do many things with this. We can add additional prompts. And let me lock this in for you here, right? We have the 3 steps of the agent expert workflow. Act, learn, reuse. Planning is where we are concretely reusing this information, okay? Also, we're reusing in our question prompt, right? Now, where are we acting? We're acting, of course, in the build step. After the plan is generated using the expertise, after we validate the expertise against the raw source of truth, we are then building against that plan. That build prompt that we kick off here, this is the act step. There is useful action that's been taken against the expertise that must be updated, must be synced. And of course, self-improve is our learn step. Okay, our agents have to learn and update its mental model around the use case of WebSockets in the code base. If this has clicked for you, you might already be thinking of agent experts you want to deploy into your code base, right? These are code base agent experts. If you stop this lesson right now, you should have tons of valuable things to build out in your agentic layer of your code base with the agent experts pattern. Okay, so I just want to give you a few of my favorite examples of powerful agent experts you can deploy and build out. My top one that's literally saved me money is the billing agent expert. whatever your billing system is, however you have that connected to your back end, right? Your webhooks that respond to the billing events, the front end, build an expert here, okay? Don't miss anything here, right? Basically, the higher the risk, the higher the intensity, experts are really, really great here. And that makes sense, right? The phrase expert is perfectly fitting for this pattern. What else? Database agents, just like we mentioned here, right? The database is one of the most important pieces of every application. How you structure this determines how everything else works, runs, and integrates back into your database. So database experts are fantastic. DevOps agent experts, right? We have integration agent experts, especially when you have a tricky in-house or third-party integration or 3 to 4 way integrations. ML data science agent experts are great. You can build experts that know your data sets, that know your AI tooling, that know your agent sandboxes, that know your available compute. And just to mention it, what we've built here so far with our 2 agent experts, these are relatively simple. They have no custom tools. They have no specialized system prompt. This is just the beginning of what's possible. All right. What else do we have, right? We have API agent experts, so you can keep your front end and your back end synced perfectly. And one of my favorites, like just a data types, right? Data models, data structure agent expert to keep all of your data types across all of your 1 to N code base and microservices, keep them all in sync. This is super powerful and it's a great starting place for your first agent expert because there's really just a handful of type files that you need your expertise data structure and self-improve prompt to reference. Okay, there are many, many more. That should give you an idea of a few places you can get started. Okay, let's take a moment here to step outside engineering agent experts that are all about running your code base and supercharging your agentic layer and take a look at product agent experts. So what we're going to look at here is a seed of an idea of how you can use the agent expert pattern to enhance your user experiences. We have Nile. This is a shopping application. This example is rough. Agents are not ready to be shopping recommendation engines yet. They're too slow. But what we have here in this mock app that I had a few agents create for us, what we have here is the key ideas for agent experts inside of your user interfaces. All right, I have this really blatant panel built into this demo application. You can check out act, learn, reuse. This is what it's all about. This is the agent expert pattern. Now, when we put this into a UI, this is where things get really interesting, right? The key is to constantly build up your agent's mental model. In this case, right, when we start deploying it against hundreds and thousands of real users, it means we're going to have a data structure, a mental model per user. All right. Now this gets very, very powerful, right? This is personalization to the max, and especially when you combine that with generative UI. This generation was created by a powerful Opus model. I'm going to drop this down to a Haiku model just for speed purposes. And so I have this in the agent expert. And you can tell here my mental model around this is still pretty fresh because I was able to hop to that very quickly. So, we'll refresh this and let's just walk through what's happening here. So right now, our agent is building out a personalized experience for us in the shopping experience. Okay. Again, Control K to see our blatant expertise file in the UI. It has seen nothing. There's no expertise on me yet, right? I'm a new user. But as soon as I take a useful action, that changes completely. Let's do it. So I'm going to close this and let's say I'm interested in let's just do a search here, right? Let's say I'm interested in, let's get real. We're all looking for that, NVIDIA DGX, okay? So these are all mock products, by the way. These don't represent the real companies or products in any way, okay? So I'm going to add this to my cart and then I'm going to come back to the landing page. Now, check out what's going to happen here. So based on your interest in AI workstations and professional computing, my agent is going to start streaming in generative UI to help me complete my workstation. All right, so we got NVIDIA GPU acceleration, we got some standing desks, we got some professional displays, right? You get the idea of what's happening here, okay? The key here is it's not the application, right? Again, agents are not ready for product-based recommendation engines. There are many better and faster ways to do this, but the key here is the agent expert pattern, act, learn, reuse. What did I do here? If we click recent actions, you can see something really cool here, right? We have really blatantly, I want to just spell this out for you so you can get this advantage as soon as possible. Reuse, we have an act step here. So as soon as we viewed that NVIDIA DGX Spark, that was an action that our agent could learn. Okay, so here's our viewed products in our expertise file. Per user expertise file, we have the source table. I really want to make this as clear as possible for you so you can ideate on how powerful this can be to shape personalized user experiences, all right? So you have expertise data, and you can see the data structure of this, right? So this is the mental model for our expertise agent. Viewed products, added to cart, and checked out, okay? And you can imagine we can apply some priority to the recency and the scale of what matters more here, right? Then we have another action, right? We added this product to our cart, and that's a great opportunity to learn again. The user clicked on this, it did this action, this means that, right? X means Y, right? Based on all the users we've seen, right? Based on X star or XI, this means Y, okay? So this means we can infer this. Right here, we're just using personalized user actions. Of course, in real recommendation engines, you're going to want to look at the entire graph of when users click this, when they click this category, this price range, they also wanted that and that and that, right? This is just the seed of this big idea that you can deploy agent experts against, all right? So act, and then we have another learn, and guess what? We reused it when we regenerated this page. So we can continue with this, okay? Say we want to look at this fan, right? Fantastic, right? So we have this, or sorry, not this fan, Blackwell GPU, all right? So we add that, great. And then we can come back. And over, our agent is going to shape the user experience, right? Based on your interest in NVIDIA GPUs and professional workstations. It's going to give us new components, new UIs, new products to look at, all right? So there we go. We now need a powerful processor. Fantastic. And then we've got some random stuff here. You always want to insert some, new directions for your agents to go down, a new graph, a new pipeline. I've encoded the system prompt in here as well. This is super key. This is the formatted mode. Let's go to raw. And you can see this is the actual system prompt of this custom shopping agent expert. So you can see here, dynamic variables. We have the checked out products, nothing yet, but products added to cart, right? This is embedded inside the system prompt. You can put this in the system prompt or the user prompt. We have our viewed products here, and then we have available categories. And then we start getting into the instructions and the actual system of the prompt. And we can, of course, just crack this open, right? Let's go ahead and look at the real version. Underscore system prompt. We can quickly reference all of our agent system prompts here. And then we can just take a look at this structure for a moment. This is what's guiding the shopping experience. It is incredible that you can build something like this that could potentially guide and steer high value user experiences, right? Adaptive user experiences inside of a single prompt. Of course, there's some more prompt and some legitimate engineering work that needs to happen to use this agent, but it's very powerful that in natural language, we can define so many rules about how we want our engines of adaptive user experience to work. For instance, right? We have variables here. If we close dynamic variables, you'll see our static variables, and we can just quickly change products per section and the sections range, right? So we just have these variables that dictate how many items show up, how many products show up. We have a nice set of instructions here and so on and so forth. This is all going to be available to you to check out. The key here is, what have we done? We've taken our agent expertise, we've applied it to a per user basis level, and then we've created a prompt that can guide that individual user experience by generating components on the fly. This is just one example of how you can set up your agent experts inside of your products. All right, so I just want to give you this idea. Some engineers are already on this pathway, but the key here is that user specific data, right? That down to that action level, so that when they act, your agent learns, and then it reuses to enhance the experience. Now, as we continue to add things and as your user takes actions, right, over and over and over, say we add a bunch of those, say we're looking for some more storage, right, we add a bunch of these, we want some monitors, or say we want, some type of great device, right? As your user does more and more things in your system, and then checks out this insane shopping spree here, something is going to happen to your expertise file and to your information about your user, right? It's going to become overloaded. And this starts to push us into the challenges and trade-offs of all types of agent experts. Let's talk challenges, trade-offs, and when to use agent experts. So the first problem you're going to run into when building agent experts is seeding. What is seeding? It is, of course, that first version of your agent's expertise. So it doesn't matter if we're talking WebSockets, if we're talking database, it doesn't matter what we're talking. What does that first version of this data structure look like? Some engineers might say I'm anthropomorphizing agents a bit too much, but I think this is true, right? It's the same thing as showing up at a new job. Someone usually gives you the high level rough rundown of the code base, of all your tools, of your processes. Do you guys write product documents? What's the review process like? How do you guys run your Git branches, right? There's a whole world of how we do things here. And you'll have to seed that information for your experts. I personally like to stay relatively hands-off unless I know what I want that shape of the expertise to look like. But really, you just want your agent to not be too verbose, but don't be too high level either, okay? And you define all of this in that self-improve prompt, right? This is your self-improving template meta prompt. Start simple. Again, you're going to have all of this code available to you just as a starting place. Take it, improve it, make it your own, make it fit your use case. Hundreds, thousands of engineers are going to see this, so I can't be too prescriptive, okay? Take it, make it your own, understand the pattern, act, learn, reuse, prompt first so that you can execute it by hand manually. You can iterate quickly, then scale it into whatever abstraction you want. But seeding is all about not being too specific. Ideally, you run your self-improve prompt and it creates the expertise from blank, and then you can update your self-improve, tweak it, and rerun it, right? You can rerun your self-improve as many times as you need to, and you really want to run it until your agent stops finding new things, right? When its mental model does lock in with a sufficiently smart enough model, it will stop looking for improvements. So what's another problem and trade-off with agent experts? Some engineers will say, now I have to maintain another source of truth. Once again, this is not a source of truth. This is a mental model, okay? And your agent should take care of this for you if you write a good enough self-improve prompt, okay? This is a trend among all agentic coding, among all agentic engineering. You will have to invest in teaching your agents how to do things. That is the next massive gap between engineers. Who taught their agents how to run things and who didn't? Who's still prompting in the loop by hand that same prompt they wrote months ago over and over and over, okay? This is where winners are going to start emerging. They type one prompt, right? I typed one prompt and a feature was built out. We'll have to invest in getting it right. What's another problem with agent experts? Finite context problem. You do not want this file to infinitely grow. It just cannot. But this shouldn't be that hard to manage. Your mental model of all the code bases you've ever operated in, it doesn't infinitely grow, right? It grows at some steady pace as you understand things. And then once you get to a certain level, you just forget. That is okay. The question is, can you, based on your mental model, get back in to all the critical parts of that system? I have had no problem staying under 1,000 lines in the systems I operate in with my expertise files. And we are operating here in YAML. There are many more compressed ways to express your data structures. Play with them, experiment with them, pick your favorite. I'm sure new ones will or have emerged to best express information to agents concisely, keeping that token cost low. But I really like YAML so far. Of course, the database is going to be that primary location, right? JSON, B blobs for your expertise. Finite context is a thing. That's why I have the max line limitation. And that's why it's reinforced in the prompt. The agent must enforce this on itself, okay? Enforce line number. This is a validation check. I could probably merge these two steps, but it doesn't matter. What else is a problem? We talked about multiple sources of truth. False expertise is an interesting one. What if your agent updates something and it's just wrong, right, in its mental model? Over time, as models continue to improve, this error rate will go down. There's not really a lot we can do about this because, you and I make this exact same mistake. All these agents are trained on our data, our information, even the synthetic data coming out of these models during these big training loops. It's still based on human behavior, human patterns, right? Everything other engineers have done in the past. So there will always be errors and hallucinations. I don't think this ever goes away. There will be great sophisticated models to fact check things, but this will be a problem. False expertise will arise. It does arise. I have false expertise in some areas. You have false expertise. Expect this, okay? So we also have too granular of expertise. This is a prompt engineering problem. You need to be more specific about how vague things should be, all right? So again, I have this line here, prioritize actionable, high value expertise over verbose documentation. You might need to go on about this, add more detail about this. And again, you can specify the structure of your expertise file. Just be careful. You don't want to be too over prescriptive unless you do, okay? I would steer a little bit more on the autonomy side though. Let your agents decide what's important, decide how to track their own mental model, right? It's their mental model, not yours. And then the problem that I've started running into is this. at some level, once you start deploying these agent experts and realizing how powerful they are, you'll have quite a few of them. And then you'll need to create processes around communicating this mostly to you and your team, but communicating when to use an expert and when to just deploy a generic forgetful agent. Sometimes that fresh look is important. So too many agent experts, there are patterns here that you get into. You can build routers, reminders, you can roll these into skills or agents that automatically get picked up based on their reference point in the description. That's a problem to tackle later when it's a problem, okay? My recommendation is if you're starting to build many agent experts, that's a good thing. Look at the agent experts file before you start working on something, make that a practice for your team, and get after it, all right? Now that we've addressed the trade-offs, let's make it super clear when you want to build an agent expert. When do you want to build an agent expert? Let's go ahead and collapse everything and focus in here. They're great for user-specific use cases. In fact, I'm betting great user-facing products of the future are going to be agent-driven. They're going to be agent experts, right? In the absolute best case, a single agent will have an entire database of information about a user that it can execute on, right? Depending on where you are in the future, you might be seeing this already in many agent-first applications. The trick here is to keep latency down while your agent figures things out. We're going to need to deploy a lot of UI hacks. We're going to need to communicate active loading bars, things in the meantime to keep the user engaged while the agent really builds the best possible experience in the background via tool calls and whatever comes next. I highly recommend building out code-based agent experts for managing very high risk and high complexity areas of your code base. For instance, I don't build any billing system or any security-focused layer without building an expert. So I can always just ask my expert questions. I can query my experts about specific areas so they can manage it better than I ever could, right? And that expertise file, right, it doesn't get fuzzy like our expertise does. Their expertise file is just there. It's always there. I have caught revenue changing details, and let me be super clear here. My agent experts have caught revenue changing details in these systems and security specific details because they were experts. They had all the details of all the nitty gritty things, right? And I'll bet you have, if you've been an expert in a specific area of your code base, you know that there are some tricky tricks. There are some tricky tricks that can get even the best engineers, okay? We're talking down to runtime execution of nasty SQL ORMs. We're talking about ML models that if you don't tune that one variable, right, that one setting, it messes everything up. There are many examples like this throughout engineering, so many foot guns, so many issues, especially as your product grows. And this is a key idea I want to communicate to you. If your product is successful, it will grow in complexity and speciality. As that happens, agent experts become more and more valuable to help you manage that complexity. When you set up the right act, learn, reuse structure for your agent experts, and when you dial in or let your agent manage that data structure, right? The shape of that mental model, okay? So as the complexity, as the size of your code base grows, the agent expert becomes more valuable. So I also recommend you build an agent expert when you see high error rates around specific areas of your code base where you keep trying to deploy an agent and they keep getting it wrong. This is where you can deploy a specific agent expert, right? You can come into your self-improve prompt and modify a couple key ideas that say, hey, pay strong attention to this idea. Make sure this is part of your mental model, okay? It's okay to be prescriptive, right? Some of engineering is very prescriptive. We don't want anything fancy happening here, okay? So when should you not use an agent expert? Avoid this if your problem doesn't evolve or change over time. There's a part of your code bases, a part of your products that just hasn't changed, right? So who cares, right? Why do you need a dynamic, evolving agent for that? You don't. Deploy an out-of-the-box generic agent that's just that, classic good engineering agent and just have it solve the problem, okay? If you don't need a mental model to be maintained to solve the problem well, there's no reason to build an expert, okay? Build a prompt, build a one-off agent, build a skill, call it a day. Keep it simple. For simpler code bases, so if you're creating a new code base, what is new about that? A lot of code bases when they start, I can almost guarantee you your language model, your agent has seen that exact code base already in a couple different shapes and forms. Okay, it's not till your code base gets unique and starts generating unique value that an agent expert becomes valuable. All right. Another reason to not use an expert is when you yourself do not have a mental model in place. If you don't know what you're building an expert against, how can you know if it's performing well? Okay. If you don't understand the problem, do not build an agent expert. You will build an expert that can't solve the problem because you can't. It'll make your problems worse, not better. Agent experts, as they loop around that knowledge, their performance does have some type of compounding effect to it. A couple things to mention here. You can build agent experts with memory files if you like. You can have them auto update the memory file. I don't like memory files. We've talked about this in Agentic Horizon. These memory files are always loaded, even when you use some type of rules or glob pattern matching. Memory is only added if you're in certain directories, right? This won't be able to detach when the time is right. Memory files are very valuable. I just wanted to mention that here. I think for experts, you want a dedicated, isolated file, and you want to explicitly say, hey, expert, I need you. Help me do this. Agent skills are great for this. You can build out your agent experts as a skill, as I mentioned. This does not matter. Okay, skills boil down to prompts. Okay, if you like the ergonomics of that, if you like the ergonomics of a sub-agent so you can parallelize it, use whatever abstraction you want. Just remember, I always like to stay close to that bare metal, so I recommend the same for you. Everything becomes the core four: context, model, prompt, tools. Every abstraction on top of that, it's just that. It's an abstraction. It boils down to the same thing. I focus a lot more on principles of AI coding and tend to avoid these abstractions for, especially like for these new patterns, right? What is it really, right? What is an agent expert really? You don't want it to be intermingled with existing other abstractions. Things get confusing then. But again, build whatever works for you and your team. I'm not trying to sell you on any particular idea. Take the pieces here that you like, take the pieces here that work, and build experts in your own way. Okay. So when we zoom out and when we look around, experts are the true value generators of the world. They're the 80-20 of the world, right? Of engineering, of business, of whatever you're in. True expertise is what people pay for. Expertise drives true innovation and change. For example, right? Like in the tech ecosystem, data scientists, ML engineers, AI engineers, agentic engineers, engineers that build the system are the cream of crop for engineering. Why is that? It's because there is expertise required here. We are in a loop of ever-growing act, learn, reuse loops that builds our expertise. So inside of your code bases, whenever you have niche information or you want to build a specialized operator for a specific problem in your code base, consider building an agent expert. Inside of your products, I highly recommend you start experimenting with product-focused agent experts that let you build adaptive UI UX for your users. I think there's a whole new class of products waiting to be built on top of this pattern, on top of agent experts. Here's a simple question for you as we part ways today. Do you want a generalist working on your code base that forgets every time they work? Or do you want an expert that remembers and learns from the work done so that the next time they show up, they start with a powerful working understanding of the system? Great work here. In the final lesson of Agentic Horizon, we'll focus on one of the most important topics of agentic engineering: code-based architecture in a world where agents are the best tool for engineering. We'll cover optimal shapes for your code base so you can scale the performance of your agentic layer. We'll tie it all back to the one big idea of tactical agentic coding and Agentic Horizon. You and I, the agentic engineer, we build the system that builds the system. We prioritize agentics. I'll see you in the final lesson of Agentic Horizon.